Hello children, let's continue with the chapter 7, Electricity and Magnetism. Now we will learn about electromagnetism. Here in this diagram you can see this is a soft iron core and a copper wire, insulated copper wire is wound around this soft iron core. When electric current is passed through this coil of insulated wire which is wound around this soft iron core, okay, then this soft iron core behaves like a magnet. Okay, it can be said as a temporary magnet because the magnetic behavior lasts for as long as the current flows through it. You can see here bits of iron pin, it gets attracted toward this soft iron core. Okay, and this magnetic property remains as long as electric current is flowing through this copper wire. When we switch off the electric current, again this iron pin falls down. Okay, so this is a temporary magnet. And if we want to make it a permanent magnet, then in spite of this soft iron core, we can use a steel or a special alloy. Okay, then permanent magnets can be made. The strength of the electromagnet, it depends upon the amount of current flowing through the coil. If more current will flow through the coil, the electromagnet will be stronger. Okay, and if less current will flow, then it will be less strong. Okay, and the strength of the electromagnet also depends upon the number of turns in the coil. How many turns we have made, this winding, how many turns it is made. Okay, we can increase the strength of the magnet by increasing the number of turns. Electromagnets, they have a wide range of application. Okay, they are used in different fields. For example, it is used in the mining industries to separate the iron ore from other materials. Okay, then it is used for the electric motors, electric bells or the electronic switches. Okay, it is used for lifting heavy loads of iron or vehicles and scraps. Okay, now let us understand the electric bell which works on the principle of electromagnetism. An electric bell, it consists of the U-shaped electromagnet, an armature, a hammer which is attached to the armature, and the gong. Okay, this is the gong on which this hammer will strike. The armature, it is nothing but a strip, iron strip that faces this electromagnet. Okay, this hammer which is made up of steel, it is attached to the armature. There is a contact adjustment screw, okay, which consists of this brass screw, we can say, with a tip made up of silver, okay, which is attached to this spring, contact spring. Let us understand its working. Now what happens when the switch is pressed? Okay, here you can see this is the switch. When the switch is pressed, the current starts flowing to the electromagnet. Okay, and when the current starts flowing, okay, this electromagnet, okay, this iron core gets magnetized. And then what happened when this iron core gets magnetized, it attracts the armature. This is the armature. As it attracts the armature, then what happens? Along with it, this hammer moves, it moves along with the armature and strikes the gong. Okay, the armature moves towards the electromagnet, and thus finally what happens? The hammer strikes the gong, because of which it results in the ringing sound. Okay, so when this hammer moves, or when the armature moves toward this electromagnet, automatically what happens? There is a break in the circuit. Okay, as it moves down, there is as this one moves down, this automatically the circuit breaks. Okay, and the current stops flowing. So now when the current stops flowing, again the electromagnet loses its magnetism. And again, when the electromagnet loses its magnetism, again armature goes to its same place where it was. Again it moves back to its original place. Did you get it? So as long as the switch remains pressed, okay, this bell keeps on ringing. It goes on repeated ringing.